Guys ready? Class?
Yes.
Okay, that's better. That's better. Okay. That was a nice E flat, but, we're working on it. Yes, it works this time. Okay. So I'm going to do my best to actually make this easy. There we go, for all those people that are gone. So, not the whole thing. Now, we've already done all these, right? You don't remember? Okay. You know that cotangent is reciprocal of tangent, right? That's what that means. You know that secant is the reciprocal of cosine, okay, and cosecant is the reciprocal of sine, right? Okay, good. Quotient identities means tangent is sine over cosine, which is also just y over x, right? Say yes. Yeah, y over x. Because cotangent, which I have right here, is x over y. Ooh, wow, that's not lined up at all. All right, so sine is y, cosine is x, right? Yes? Okay, good. Next one, so cotangent is x over y. Now, I'm going to show you how to get these other things right here. So cosine times tangent is supposed to be equal to sine. Now, if you notice, I don't have the angles on here. I don't. It doesn't say my alpha, my beta, my theta, or my x's. Now, in a unit circle, on my identities, the R value is always, say 1. Yeah, on the unit circle, because the unit circle, the radius is always 1, right? Say yes. So all my identities, the R value is always 1. All my identities, the R value is always 1. Okay? So cosine, we know cosine. What did we say cosine is? X over R. X over R. So if you totally forgot, it is right here on the first page, second page. Second page, there it is, second page. On the back, the formula sheet, it says definition of trigonometric functions, and off to the right hand side, where it says your sine, cosine, tangent, all those good things. Right there, okay? Did you guys see them? Okay, good. Anyone need to find this or highlighter or lowlighter? You don't have that one? Okay, yeah, you got it. Okay. All right, so cosine. So cosine is what over what? X over R. And what did I say R is? Okay, so I'm going to change this. So I'm going to translate this into algebra. So cosine is x over 1, right? Because R value is always 1 when we're dealing with the identities.
Wait, it's difference identities? Or which one is it? Oh, okay.
Times. Now, what do we say tangent is? What is it? Y over x. So watch this. It's y over x.
Cancel the x's.
Cancel the x's. Why am I canceling the x's? Very good. I have one on top and I have one on bottom, and there's multiplication happening here, right? So what I'm going to do here is I'm going to cancel out those x's. So when I'm done, what's going to be left on top? Y. And on bottom? 1. So y over 1. Now let's go back to, what is sine supposed to be? So its sine is y over R. But what did we say R is? So this is just y over 1. So is this right here equal to, same thing there? Yeah. That's all we're doing. So by the way I'm showing you how to do this, this is called a translation. So we're translating it from trigonometry and we're translating it to algebra. So we're starting from trigonometry I translate it using x, y, and r into algebra, and then when we're done, we could translate my answer back. Because my answer was y over 1, which eventually translate backs up to just sine. Right? Does that make sense, or am I making complete nonsense?
Sense.
Okay, any questions so far? And that's actually the basis of what we're going to be doing here for this unit. Now let's go back to the next one. So sine times cotangent is supposed to be cosine. Come on, come on. All right, so let's see. So this is in trigonometry, right? So we're going to translate this into algebra, right? So let's translate it into algebra. So what is sine going to translate to? Y over 1, very good. So I get y over 1 times cotangent x over y. And from right there, yes.
Okay, so when you put y over 1, you're just putting the 1 because it's supposed to be r. But
Yes, r is always 1 in all my identities. Does that make sense? Okay, good. So what's going to happen now? Cancel those y's. Yeah. Cancel the y's. So what's going to be left? X over 1, right? And x over 1. What is the x over 1 going to give me? Cosine, right? That translates back into cosine. And that's what my answer was.
Oh, they're always going to be equal? Oh, yeah.
Yeah, because there's that equal sign in between, so that means that they are going to be equal. I just got to see how it gets there.
Okay.
And by what we're doing is we're changing it to algebra, doing a little bit of algebra work, and then coming back to my answers. Does this make sense? Yeah? Okay, good. Okay, so I got all those quotient identities. Now let's take a look at some of these others. Now, Pythagorean identities. We've done some of these before. We know that this first one is going to be y squared plus x squared equals 1. Or the other way that we used to write it was x squared plus y squared equals 1. We're going to use these over and over again. And just in different ways. So now I'm going to show you what it looks like in translated to algebra. So you can see it later. So this translated algebra is going to be, let me see, tangent is y over x squared, because each item is going to be squared. So I could write it like this, or I could put the square over each one, which is also the same, and it's probably going to be, you know what, that's probably going to be the more useful way of using it. Square, square, plus 1, which is just going to be 1, right? Because 1 squared is 1. And that's equal to secant squared. But what do we know secant is? Reciprocal of cosine, right? And if you're looking at your paper with the reference sheet, it's r over x. R over x. So now, r over x. So what do we say r is? 1. So this is going to be 1 over x. And since it's secant squared, it's going to become x squared. I'm not putting the square on the 1 because what is 1 squared? Yeah, just 1. So we are going to use that. Does that make sense? Anyone? Question?
What about the y in this situation?
Where's what?
Like, you know, it's y squared, and then maybe anyway, yeah.
Y squared over x squared. Because this is tangent, right?
Yeah.
And tangent is y over x, right? And the whole tangent is squared. So that's why you have a square here and a square there. I could put the square here if you want. Is that what you're saying?
No, like, because You know how there's x squared at the bottom
Yes.
and there's no y squared at the top?
Yeah.
Why is that?
For which one? On secant?
Yeah, like you see. Yeah.
Okay, the tangent?
Yeah.
Tangent is y over x, right? And secant is 1 over x. Because my r value is 1 here, right? Or it's r over x, but r is 1. Does that make sense?
Yeah.
Okay. And then I'm going to do this last one here. So the last one's going to turn into 1 plus cotangent, which is x over y, right? X over y, so it's x squared over y squared is equal to, now cosecant. Cosecant, so if you're looking at your paper, cosecant is 1 over y, right? 1 over y, and since it's squared, it's 1 over y squared. So those are going to be helpful for later on. You're going to be using those, and this is all in algebra form. So we translated this into algebra so we could use it again later. Does that make sense? Hopefully? Like I said, this is why we're slowly going into this. Treating it like it is a new language. Angle, degrees, real number, variable. Okay. All right, we've actually done this same problem. In 2 different units, we did the same problem. So again, I'm not going to assume that you remember anything, okay? Because a lot of people over break, okay, did way too many, sugar cookies or gingerbread or whatever. What do you guys eat over holidays? Seriously, I don't know. I'm a Scrooge, so I really didn't do much of anything. I didn't put up any decorations. Yesterday, I actually fulfilled one of my requirements for my life goal. I went out the front door of my house and I yelled at some kids that were on my lawn.
No way.
But my lawn is 5 acres, so they were driving their quads through my yard. So,
Where do you live at?
I'm not telling you. Quit stalking me.
Okay.
Okay. So, but yes, I got to open up my door and yell at people and be like, "Get off my lawn!" Yeah, because they were riding dirt bikes through there. Anyway. What? Mm-hmm. Yeah. Thanks. All right. First, tangent. Tangent is supposed to be what over what? Y over x. Very good. So tangent is y over x. So there's a y here and there's an x down here. So the 3 things I always need to know is x, y, and r. Thank you. All right, x, y, and r. So x equals, y equals, and r equals. Now, one of these has to be negative, but not both of them. One of them has to be negative. This right here,
Always positive.
huh?
R.
R is always going to be positive, yes. What do we know about quadrant 2? X is negative in quadrant 2, isn't it? So x is negative in quadrant 2, and we know that y is positive in quadrant 2, right?
Yeah.
That's where we're using this to figure out. So one of these has to be negative, so that means that my x has to be negative. Yep, so I'm going to have my x value is negative 3. My y value is positive 5. And what am I missing? R. Is there an identity or a theorem to be able to solve for R? Yeah, Pythagorean Theorem, right?
Isn't it like 4?
It could be, but it's not. Because my Pythagorean identity says x squared plus y squared is equal to r squared. That is the Pythagorean identity, which used to be just a squared plus b squared equals c squared, but we are making it useful for trigonometry. X squared, so in parentheses, negative 3, close square, plus y, which is 5, close square, is equal to r squared. Now, if you remember, I put the parentheses in the negative in the parentheses here. Because when I square it, I have to square the negative. I have to square that. And when I square a negative, it's going to make that one positive. So this is going to give me negative 3 squared. So that's negative 3 times negative 3 is positive 9. Plus 5 squared is equal to r squared. Combine those together, I get 34 is equal to r squared. And how do we undo that square? Yeah, very good. So we're going to square root both sides. But what can I not forget? Plus or minus the square root of 34. But what did we know about r? It's always positive, right? R is always positive. That's always my hypotenuse. It's always the radius of my circle. It is always going to be positive. So I'm just going to say square root of 34. I can't really factor it out. So it's just going to be like that. So it doesn't factor, so I'm going to use that. Now, what do we know about secant? What is secant supposed to be? Reciprocal of cosine. So I heard an r and a something. R over x. Do I know what the r is? Do I know what the x is? Okay. So secant is r over x. So my r value is square root of 34. And my x value is negative 3. So we actually did the same problem, I think back in unit 1 or 2, when we first started doing x, y's, and r's. And that's the reason why I keep doing it the same way over and over again. Use x, y, and r over and over again instead of actually making more work for yourself. Does that make sense or nonsense?
Wait, secant is what? X over R?
No.
R over X.
R over x. Where's your reference sheet? That did you lose it already?
No, I have it.
Oh, you just didn't want to.
Yeah.
Oh, okay, thanks. Next one. So I always stop, but the problem is we have a part B, and I think we even have part C. Yeah. Okay, sine theta. Sine theta. What do we know sine is? Y over r. So it's the same problem. Do I know what the y is? What do we say? 5, and the r is square root of 34, right? Can I leave it like that? No. What's that called? Rationalize. Rationalize. See? You knew it. Just beat you to it. So right here, square root of 34 times square root of 34. So on top, I multiply straight across. 5 square root of 34 over. There we go. Is that easy now?
Yeah.
You guys feel pretty good about that now? Okay, good. This next one. Cotangent of a negative theta. So that means.
Whose number is that right there?
Who's what?
Number.
Your mom. Yeah, she came in and she's like, yo, hey, let me drop these digits here. Okay, so cotangent of negative theta. So let's go back to right here. Cotangent negative theta. Right here. I just solve it normally. Then what do I do in front of it? Put a negative. Solve it normally, then add a negative. Let's go ahead and solve it normally. So cotangent. So cotangent. What is cotangent supposed to be? X over y. So my x value, what was my x value? Over y, right? Okay. And given that, what do I need to do now? Make it a, put a negative out there, right? And 2 negatives make it a? Thank you. So my answer is positive 3 over 5. there we go. I'm gonna stop there, and I'm gonna put up some problems and let you guys start on those. But I'm not gonna assign it yet because I want to give you guys time to make sure everyone is on board here.